Derek with MillRight CNC. I'm here with the Alpha Arc plasma table. We're going to be cutting some 10 gauge. We're going to make a helmet holder that goes on our welding tape. Let's take a look at this. Got my Masso control up. I'll hit the rewind button. Start cycle. Let's check it out. Pull that bad boy out of there. All right, guys, we've got the piece plasma cut. We bent it on our brake. We tumbled it a little bit, threw some paint on it. I'm really happy with how it turned out. I think it's going to be good and functional for us. I saw something like this for sale on the internet for 85 bucks. And I'm thinking, 85 bucks, we could definitely do that ourselves. The steel's not that expensive, and a little bit of spray paint, a few minutes of work. You saw the Alpha Arc cut it in like a minute and some change. That's one of the things that I think could kind of open up your projects for a lot of our woodworker customers that are already on our routers. There's a lot of people that will pay for stuff like this and metal signs, and I think the Alpha Arc opens that up. But if you wanted me to make one of these for you for 85 bucks, and I'll make you one, or I'll make you 1,000. I'll even do it for 80. But look into the Alpha Arc plasma cutting. If you're already doing some woodworking and you've already got customers, they're going to want some metal work too. You can definitely find those customers and offer metal signs and a lot of cool things like this. So let's put it on, see how it looks. It just slips right in here. Boom. There we go. So we can hang our gloves on it. We can hang our helmet on it. Got some holes here to put various things. There we go. I'm going to show you guys how to use Fusion 360 to generate G-code for your Alpha Arc plasma table. So I'm in the manufacturing workspace here, or just manufacture. You can go over to design, and there's another tutorial that will show you how to make a file, but let's roll on over to the manufacturer workspace, and I'm going to go to fabrication. So the default tab here is milling, but we want to go to fabrication, and from here you're going to do a new setup. So you'll click that, and by default, if you already had something, it would probably give you a relative size box, and you can turn additional stock off because you don't need it for this type of operation. But let's say I'm setting up something new here. I'm going to select this as my stock box point just because I wanted that lower left corner. You'll notice that it's not really the way I want it. I want this direction here to be the Y and this to be the X. So I'm going to change from model orientation to selecting Z-axis and X-axis. For the Z-axis, I'll just select the top. For the X-axis, I can select an edge that is oriented along the x-axis. I'll do that, and then I need to move my stock point back over here. Tell it OK, and I have it set up. Of course, I've already done that here. You see this previous setup where I already have these profile toolpaths set up. From there, you're just going to go to cutting and set up a 2D profile. So every one of these is going to be a 2D profile, and I started out with cutting the little MR logo here. I actually kind of poorly programmed this because I caused it to run back over. I should have planned that out a little bit better because I had the torch move back over. I probably should have put a tab in here or something like that to keep this from popping up. You may have noticed in the video the torch just bumped it. Not enough to trigger the breakaway, but it bumped it and it recentered on the magnet. So it worked out, but only because I was lucky, not because I was smart. Let's just take a look at this here. So I'm going to edit this path. If you were just starting this out, you would click on geometry here, and you would select the geometries. Here I just select the top surface of the geometry. I could select it down here and it would work out the same, but I've just selected the top. For my heights, I don't manipulate that a lot when I'm doing plasma cutting. Moving on here to our passes tab. I've enabled smoothing, and I do suggest that, especially if you've pulled something off like one of those free DXF websites. A lot of times they're really jaggedy. I smooth this and I put a smoothing tolerance of 4 thou, and I'm going to kind of show you why that matters real quick. So this is my G code that I ultimately ran, okay? And you see it's, I don't know, somewhere around 600-800 lines. This is the G code without smoothing. It's about 1,800 lines. Now that in itself isn't really scary, but what you're running into is it's breaking things up into a lot more segments than if you turn on that smoothing. It's just a helmet holder that goes on a welding tank. So a 4 thou smoothing tolerance is going to be fine. The part's not going to function any different. And if you're looking for something closer than 4 thou, you ought to be milling it and not plasma cutting it anyway. From here, I have my lead ends. I like to lead in. I don't like to lead out. So let's take a look at the lead in here. Let's say that this part completely dropped out. So I just have lead ends here, and you can see that there's my lead in. So I'm going to come back into this, and I'm going to turn on the lead out as well. And it's thinking about it. All right, so I've got a lead in and I've got a lead out. Say this dropped all the way into the tank, right? Say it was between slats and this R just drops out. So it comes around, it's going to lead in here, it comes around here, and the part drops right here. If it continues to lead out, it's trying to keep that arc fed with metal. So your torch height control is going to want to chase that down looking for metal. And there are ways that you can prevent it from diving, but I think it's best just to either make your lead outs very short or just turn the lead out off altogether. So I'm going to uncheck the lead out. And I did select a particular position. You can, if you don't select a preferred lead in position, it'll kind of decide on its own where to lead in. But on this particular one, I wanted it to lead in right there. I could have chosen something for this here. So I broke the profile up, or the job up, into 3 different operations. I did this one first, which is doing the MR, and then I did the holes, and then I did the contour. Reason for that is I wanted to use different lead in settings for each. For instance, this big lead in and lead out here, I actually did leave the lead out there. I didn't care because I knew there would still be like the main body of metal. But you look at something like this, we're cutting a hole. I know that's almost certainly going to drop out. So if I lead in, it drops it out, and I lead out, it's going to want to dive into this hole. Again, here, it didn't matter because I knew that I had a larger sheet of metal and it would find something to cut right here as it let out. One thing that I've done is I'm going to reference this chart here. So not that. We're going to pull up. We're going to pull up this. Okay. I've got this cutting chart here. It's actually on the Alpha Arc product listing, but you'll find it in the Hypertherm manual as well. And that tells me all the different settings that I need for each. I've not done it for everything on this, but let's say I'm cutting 10 gauge. I'm going to select the settings for 10 gauge there, but we don't want to post process yet. I'm going to go over here and I'm going to select my tool. So what I do, and I'll wait for this to come up, I set up different tools for the different settings that I need. So it's all tool 112 with the Masso control. So I name it tool 112, or that's the post-processor tool number. But then like I have different settings here for 1/4 inch steel. I've got stuff like I've got the kerf settings, the cut speeds, the pierce heights are the same on the 45 sync with the standard cartridge. But I have those set up differently. So to give you just a feel for that, I'll come over here and edit the tool. And you see like post processor, the number's 112. Cutting data, I'm using 95 inches a minute for 10 gauge. That's what the Hypertherm chart says to use. Cutting heights, pierce heights, all that's the same. So I'll accept that. I'm just going to hit cancel because I already had selected what I wanted. When you want to go to post process, which is what's going to make your G code, I'm going to select the entire setup there. You have to be careful. If you just select this and tell it to post process, you're just going to get this one profile. So select the entire setup. We don't need this one. Remember, this is just a setup I showed when I was demoing how to do a setup. But I'm going to select my setup. I'll go to post process. I have various posts in here. You're going to want the Masso Plasma Masso G200 post. That's what this needs to run the Masso control with Plasma, and you use the G200 G codes, and I'll explain those in just a second. Some different settings here. I was in inches. Keep in mind whether you're in inches or millimeters whenever you give these probe feed rates, and that's how fast it's going to Z down as it looks for the material. If I have ohmic touch enabled, then it's going to use the ohmic sense to excuse me, to detect the plate. If I uncheck that, then it's going to use the floating head switch to detect the plate. But keep in mind, let's say I normally run millimeters and this is at like 2500. If I don't change that when I'm running inches, then I'm going to be hopping down into that plate faster than I want to on my probe. All right, so I'm going to leave ohmic touch enabled. My THC voltage is going to come from that Hypertherm chart, and it's labeled as arc voltage. That's the arc voltage that I want for this gauge of material with that cartridge on my Hypertherm PowerMax 45 sync. Other important things that you're going to want to do, the pierce delay also comes from the Hypertherm chart. The pierce height comes from the Hypertherm chart. The cut height comes from the Hypertherm chart. Make sure you're referencing those and that they're correct, or you're going to get some bad results in your cut. As far as other things that you want to do, I think that's about it. You don't really need to mess with this built-in. Just make sure that your pierce height, your pierce delay, the material thickness doesn't matter, but your THC voltage does. Your probe feed rate does. Minimum THC radius has to do with whether it's going to use Masso's M66 and M667 to toggle whether the THC is controlling the Z-axis, and this is something to prevent diving. So if it were doing if it had to slow the machine down as it's doing like a tiny little arc, we might want to turn the THC off so it's not burning out that material and then diving looking for new material. I'm not going to post because I already have, but I'm going to pull up the G-code that we ran and explain that to you for just a moment here. So I'm going to scroll back up to the top. All right, so the G200 code is unique to Masso, and I think that's worth understanding a little bit. So I've got G200 F100. F100 is how fast it's doing the probing. I'm in inches. I'm in inches because G20 is the code that specifies inches. But F100 is how fast it would probe. P015 is going to be the pierce height. D400, that's 400. This is milliseconds. So a delay of 400 after we pierce. C0 1.25, that's 1/8 of an inch. That's your cutting height. So after it pierces at 0.15, the arc stabilizes. It's going to start cutting at 125, and V137 is the voltage that my torch height control is trying to maintain. A0, that's an anti-dive feature that Masso, as of towards the end of 2024, they don't have enabled yet. So A0 is going to be fine. O1 is going to enable our ohmic sense. If it was O0, that's going to be your floating head, and that's just driven by the option I selected in the post processor. S0, I don't want it to stop after pierce, but if it was S1, it would pierce and then it would stop. And this is useful if you had like a thicker plate of material that takes a while to pierce, and then all that slag builds up around it and then may disrupt your contour cut if it's really close to where you pierced. Rest of it's pretty standard G-code other than this M667 and M666. M667 with this feed rate of 25, that's turning on the THC or handing over control of the Z-axis to the torch height control at the specified feed rate. And then here we've got cutting command. So you'll see two different feed rates going on here. If it's next to this M667, then that's your torch height control feed rate, how fast it's adjusting the Z-axis. M666 is turning off the torch height control. If you remember that minimum arc radius, we're turning it off so it doesn't try and chase it down where it may run out of material and dive the torch.